Hello everyone. Welcome to my YouTube video. This is Dr. Song. So today, finally, we started our inferential statistics. So until now, so many sessions, I was concentrating on explaining descriptive statistics. With that basis, now we can proceed with the inferential analysis. You will see today the many concepts about the analysis, what is inferential analysis, and then you will find the what are the basic analysis about the discourse. Discourse is constructed by the some with some content of the courses. So these are the list of the courses that I included the content to my course. So the selecting a statistical test. So you saw that many different ways how you obtain, how you clean your data when you receive the survey result. So that is about your descriptive statistics. So when you clean your data with the normality test and also the obtain the frequency table and all these things we saw in the descriptive statistics, now your data is ready to go for the inferential statistics. So we have to know before proceeding with the inferential statistics what we should know. The first thing, statistical techniques. So the researchers, they use this technique. Why? Because we want to obtain the statistic values and also the level of significance. This is referring to the p-value. So with this result, researchers can make decisions to reject or fail to reject the null hypothesis. That means that it accepts our null hypothesis. So null hypothesis means that there is no difference or is no significant result. And then you can accept the null hypothesis. There is no difference. There is no effect. And then reject the null hypothesis means that there is a significant change or significant difference. So there are two groups of statistical techniques, parametric test and the non-parametric test. Basically, the parametric test that you have to satisfy the assumptions. So each test has assumptions, and then you have when you satisfy those assumptions, that is fall down in the parametric test category. And then if not, we will proceed with the non-parametric test. So both of them require the samples. That should be the probability sampling. So that is like a random sampling. So that is like a principle of the statistical test. But in the real life, we have a lot of like a non-representative sampling. So it's not random sampling. So that is also the situation that many researchers, especially about the university students research that will be the more about the samples. They are not random. We will see about that. So parametric test, that is some assumptions should be met. So in this assumption that contains the dependent variable is continuous, and then normal distribution. Yeah, then maybe that is the most prominent assumption, a normal distribution. So we saw that what it means in the descriptive statistics. And also sample size. So sample size, we have the special calculation to see that sample size is correct for the certain analysis. So these are calculated, in fact, with some specific measure. But also, if the sample size is larger, and then that is a standard error will be smaller. So that will also generate the great power. And then normally the sample size is a smallest is a 30 subjects. And then two-tailed hypothesis requires a larger sample than the one-tailed hypothesis, because two-tailed means that just simply there is a difference or not between the two groups of the nominal variable, for instance, in the independent test. But in the one-tailed hypothesis, that becomes more complex. It's like you have to give the direction, like women are more than men, something like that. So if you just say men and women, they have a different, significant difference, that is a two-tailed. But if you give the direction, which one is higher, that becomes a one-tailed hypothesis. So that's why it's a different names. Smaller level of significance, so that is alpha 0.05, that requires the larger sample size. However, when you have the small effect size, that is also okay with the small sample size. But if you want the greater effect size, naturally you need a greater sample size. Non-parametric test. So this means that this test doesn't require the assumption met. So you don't have any assumption. For instance, dependent variable, it can be not the continuous variable, but the ordinal level, like a categorical variable. And the distribution of the dependent variable is not normally distributed. And then also smaller sample size is okay. And then that transformation means that when we obtain the data is not normally distributed, we can transform the data to make it to meet the assumption. So even though the transformation is conducted, that doesn't improve the shape of distribution normally distributed, and then we will proceed with the non-parametric test. And when a sample is drawn by the non-probability sampling, that was I was referring before, and then we should do the one sample test or the chi-square goodness of fit test. So these tests that is like with the population and compare with the population. So those tests are added to assure about the non-probability samples. Favorite means that independent and dependent variables, they have the two variables, and then normally the all parametric tests are bivariate. Paired and unpaired observation. So this is a distinction. When you go for the repeated measure, you need a paired. That means that it's the same people, the sample size same people, they have the different times. That is a paired sample. Unpaired means that they are not in the they are different groups, and then that is not in the different times, just in the one time, but they have a different groups. So that is unpaired. They are the correlation independent test, ANOVA test. Paired will be the repeated measures. It's like when you launch the medication, and then you will see in the beginning without medication how people has the like a depression level, and then after taking the then medication how the depression changes. So these are the repeated measures. At the time you can use the paired test. And then what analysis we use? So this is next question. So that is decided by your research question, like a hypothesis. And then the what is the confirm the level of measurement of variables. So that is about the continuous or categorical variable. And then you will see the based on this which analysis you take. So and then you should also think about is a parametric test. The assumption should be met or not. So these are the before choosing the analysis you have to think about. Okay, now we have the two categories, the inferential statistics. If we want to know the relationships between the two variables, we have the one test that is a chi-square. That is about the variable 1 and 2. They are both of them are categorical variables. And then you can choose the chi-square to see the relationship between the male and the female, for instance. And then they have the social media platform, like four different kinds. So if you want to know how they are different, and then you will choose the chi-square test to know about how they are different, male and female, their preferences about each social media program. And then correlation is another test for the relationship, if they are related or not. So what is the relationship between the daily hour of social media hours and the total number of Instagram followers? So this is also the continuous variable is the daily hours of social media use. Another one is the total number of Instagram followers. So the daily hours of social media, when there is increase, we guess that total number of Instagram followers also increase. So these are the relationship, how they are related, the variable and the variable 2, but they are both of them continuous. In that case, we use the correlation. And now another category of the inferential statistic is a prediction. So the first one is a t-test. So that means that it's one group of the male over female that influence the total number of Instagram followers. So which one is higher, male or female? So we can, after this obtaining the result, we can say that, oh, okay, when it's a female, the total number of Instagram followers is higher. So we can say, after obtaining the result, about the prediction of which one is higher. And and then also we have ANOVA test. ANOVA test is different from the t-test because ANOVA test require the independent variable has the three groups. T-test has only two groups, male and female is dichotomy. But ANOVA test has the three groups. So like male, female, and then maybe another group. Yeah. So and also we can say the first year student, second year, third year, fourth year. So when you have the four groups, we can proceed with the ANOVA test. And then finally, about the prediction, we have the regression test. So regression test also, there are two continuous variable and then one independent variable can predict the dependent variable. So the enjoyment of the social media use, so we will use the Likert scale, that is the independent variable. It predicts the total number of Instagram followers. So that is about another numbers. So in this case, the enjoyment is higher, and then the total number of Instagram also higher. So that is how we can know how many followers, the number we can predict. So these are the inferential statistics analysis. We will see one by one from the next session. So thank you so much for listening to this video. And the next session, we will go over one by one the inferential statistic analysis. Thank you so much. See you next time.